And welcome back. We're going to continue looking at exception handling. Last time we took a look at how to write some exception handling and how to handle some errors. But if you recall, we had a problem with our input mismatch exception. We tried using that, tried to solve it, but we couldn't quite do it. So there was some work that we said we needed to do to kind of make that happen. And that's because when we work with the Skinner class, there's a couple extra steps that we want to do, and that's what we're going to look at today. And to get started, think about what we had. We had an input mismatch with our program, all right? Because we had, for example, we're asking for an integer. We typed a letter. Oh, we got an error. Well, this whole thing comes back to when we looked at the try-catch mechanism, right? We said, hey, we got try-catch. We're going to try this code out. If it works, we're going to do it. If it doesn't work, we're going to throw an exception. So they say, all right, well, let's read in an integer from the keyboard using the nextInt method of the scanner class. The program, of course, terminated with an error message if the user entered something that wasn't an integer value. And just to recall that, let's just take a look at this code again. I went ahead and added back in some of those exception blocks, and you can see we get a divide by 0, not valid input, and some other error. So if we go ahead and say, let's say 4 and A of course is not a valid integer. You can see we got an input mismatch exception here. Even though we have a catch for it, the program didn't work the way we wanted to. We didn't get that not valid input to be handled correctly. So we obviously are going to need to look at this and create some sort of thing that's going to help us handle and address this. And as we just mentioned, and we saw that in our code, the program ended with an error message. That error message, of course, is the input mismatch exception. So let's work on catching that exception. All right, we have a catch method set up here for us to be able to work with our code. But even if we do catch it, the catch block, should do something. All right, it should allow us to have some kind of alternative action, right? Ideally, in a perfect world, if let's say they enter in a letter, well, we know a letter is not an integer, so maybe we can, instead of just trying to terminate the program, we can say, hey, maybe you want to re-enter that input. Maybe we want to get a chance for people to type something new. Now, you're not required to account for an input mismatch exception by catching it in a catch block or declaring it in a throw clause technically. All right, when you do that, because these are actually part of the runtime exceptions, so it's something that you can actually, not necessarily have to deal with. But because we are learning, it's a good practice for us to kind of get in the habit of. Now, we are allowed to catch an input mismatch exception in a catch block, which can be useful. So when we look at the input mismatch exception, the first thing you have to understand, it's in the standard Java package java.util. All right, just like our scanner class is part of java.util. So if the program mentions an input mismatch exception, then it needs an import statement such as import.util.input mismatch exception. Now we can code to require robust input for any program that uses keyboard input. We can start validating our inputs, making sure that we are having correct inputs putting in, or sanitizing out inputs that would be invalid. So here's a tip. How do we actually go through this? Well, we want to use actually an exception controlled loop. And so loops are going to come in very handy here if we want to be able to control our input and not have to deal with anything invalid. Sometimes when you have an exception thrown, such as input mismatch exception, all you want to do to fix it is you want just to repeat some code. All right, so the users can get things right on the second try. Maybe they typoed something. They meant to type in a 1 and instead they hit an L on accident, or their fingers hit something and bumped the enter key. And so you just want to give them a chance to re-enter something. Well, one way to do this is to pretty much put a loop. So every time a particular exception is thrown, you're pretty much just starting back over. So if we look at this example, we got boolean done equals false. While not done, try. We have our code that's going to throw an exception, and then we're going to say, done is now true if it's complete, and then possibly do some more code afterwards, and then of course have our catch. So how does this exception control loop actually kind of help us? Well, if the exception is thrown in the first piece of code in that try block, then the try block will simply just end before the line that sets done to true, and the loop body is repeated. If no exception is thrown, well, done is set to true, loop body is not repeated. It allows it to just continues on like we would expect it to. Now, you very much effectively, you can have some minor variations to accommodate a range of different situations for which you want to repeat code on throwing an exception, but ultimately it's going to come back to this kind of thing. You're going to have some kind of loop that's going to look to see if a condition has been met. If that condition has been met, then it's going to, of course, loop. If the condition is not met, we do what we got to do to get our input and outputs to be correctly what we want them to be. If we're, for example, looking at our integer situation here, if I'm like, well, I'm going to put a loop around it, and I'm going to look to see if those ints are valid, we're going to go ahead and make sure that they are, something that is an acceptable number. Well, great. If it's not acceptable, then we're going to go ahead and have to have these be re-inputted. And so when we look at our code here, let's go ahead and try to see if we can take this code and go ahead and add that loop in here. Well, the first thing we want to do is go ahead and create that Boolean. So let's go ahead and just add a Boolean in here, and I'm just going to go ahead and call this valid. How about is valid input? Since we know that we are going to have one, and we're going to initialize this here. We can say it's true or false, depending on how you want your loop to be set up. I'm just going to go ahead and initialize it to true. I could also just have invalid input. I can set up that way as well too. However you set this up, you just have to make sure you adjust your loop accordingly. Now, at this point, we have to ask ourselves, where is our code going to need to loop? Well, this is, of course, is the part that is triggering the input, right? But we could, of course, encapsulate all this here too, and because we could put this, please enter numbers input into our try block, and then just put our while loop around that as well. So because we know we're going to have to do that, I could leave this here, but I'm just going to go ahead and start by adding my while loop, and I'm going to do is valid input, and we're going to assume this is true. All right, so this is true. All right, we can then put our curly brackets here, and we're going to go ahead and move this whole thing here into this loop. And just tab that over. There we go. And so we say, while is valid input, please enter two numbers to divide. And we're going to get two numbers. It's going to try it. And it should effectively come back to the top of this loop. Now this says, while this is true, do this thing. Now what we do have to add, of course, is if this gets past this try block, right? How do we have to set this? Well, we need to change the is valid input to false, right? We have to change it. Now we might have to say like, hey, we want to change these around. We said, they might say this is false, this is true. However you want to set this up, and you have different names for your variables and stuff like that. So I'm just going to assume that we're assuming that this is valid input putting in, because if it's not, we're going to trigger this loop, right? So this should almost be, well, this is not a valid input. All right, well, this is not a valid input. And because now this is going to look for this to be false, well, this is false, all right, which means this would have to start as false. And then we could say, well, it's not false, or well, it's false, because then we're going to change this to true. So again, however you set that up is going to be up to you. The important thing is you want to make sure that these two conditions are different, because you want this to exit out if this is true. So let's go ahead and run our code here, and let's just go ahead and type in 4 and 0. All right, we get divided by 0. All right, cool. So that is our arithmetic exception being thrown here. And let's go ahead and run it again. Let's do like 4 and 8. All right, we get 0, okay, because we try to do 4 divided by 8, which, we're doing two integers, do 4 and 2. We get 2, awesome. Now let's go ahead and try to do 4 and A. And you can see we still threw that input mismatch exception, so it didn't actually cycle it back around. So we need to do something here to actually handle this mismatch a little bit. So let's go ahead and take off first the system x is 0, because we want this to loop. And let's just go ahead and effectively just do a keyboard.next line, because what we want to do is take this and move this carriage return down. And we're not caring about what this value is, so we're going to just end up throwing that away. And it's going to go to the next line, allowing us to get a fresh input. So we got not a valid input. All right, then what do we want to do? We could have them, of course, come back here to please enter two numbers to divide. And of course, we should see something. Let's just see if this works now. See if we have enough variance. As I do 4 and A. All right, we're still throwing the input mismatch exception here. So what do we need to do yet to kind of avoid this error? Well, there's only one other thing that we could do. If you remember before, we had these outside of a try block because we said, well, this wouldn't really necessarily cause an issue to code. However, if I go ahead and move that into my try block now, because I want this to effectively loop, and I could keep this outside the try block, but I'm just going to move the whole thing in here. What this is going to do now is it's going to, when we get these two inputs, it's going to test for validation with inside this try block. So let's go ahead and rerun this. And if I do 4 and I do A, we get not a valid input. Please enter two numbers to divide. Let's do 4 and let's do 1 now. And you can see that the program now works. And if I had, for example, not done this loop here, let's just go ahead and just take this out here. All right, just comment those two pieces out there. And let's just go ahead and save. So we're going to ignore those two pieces here. Oh, and we got an extra curly bracket here. There we go. If I go ahead and do this without the while loop in here, and I go ahead and do for an A, we notice we now get not a valid input, but our program terminates. So when we looked at this last time, we technically could have had this cleaned up here. The biggest thing is we had to look and make sure we were putting our inputs in the correct spot here, because in order for this input mismatch to be addressed, it has to be within inside the try block. So it was an interesting thing for us to kind of learn and see, but that is giving us a lot more power with what we can do now with exception handling and how we can actually make our programs be much more robust in handling errors.